do they still believe that in the center of every galaxy there's a supermassive black hole that's, what is it, 1/2 of 1% of the mass of the galaxy? Is that what it is? What purpose do you think they serve in the universe? The eclipse was wild. We had the eclipse here in Texas.
Yeah, did you see it?
Oh, yeah. It was incredible. It's so strange. The whole day turns into night. All the birds stop chirping.
So you wouldn't notice if you fell through the horizon of the black hole in the Milky Way galaxy. If you went into that one, we could be falling through that horizon now in this room, and we wouldn't notice anything, except that we couldn't get out again. And ultimately, in a few hours, in that case, time would end for us. So we just you go to the end of time.
So we wouldn't notice.
Not for the big black holes. So these supermassive black holes, we could fall across this horizon. It's just like being in empty space for us. So we would just be talking now, and we could have been talking on the outside of the horizon, and by the time I finished the sentence, we could be on the inside of the horizon, inside the black hole. And according to Einstein's theory, at least, which is the theory that predicted them initially, we could just do that. We could just go in, and we wouldn't notice for a bit. The thing we would notice ultimately is you go inexorably. Nothing you can do. You go to this thing called the singularity once you've crossed the horizon, and you are going to that thing. And then the question arises, what is that thing? And one answer is we don't know, but in Einstein's theory, it's the end of time. So one way of picturing what's happened here is so distorted is space and time by the collapse of a star or the collapse of loads of stuff to make these big supermassive black holes. We don't quite know how they form, actually, but it's collapsing stuff. So it distorts space and time so much that in a real sense, they kind of flip over. They get mixed up. And so this singularity, which you might have thought of as the point to which this thing collapsed, this infinitely dense point, you might think, but actually it's more correctly to be seen as the end of time, because everything's got mixed up. So you go to the end of time. And it's just like saying, why can't I escape that thing? It's like, why can't we escape tomorrow? Right. So we are going to tomorrow.
Right.
And if I said to you, let's run away from tomorrow, you'd go, I can't run away from tomorrow.
So is it the end of time because all information is being erased, so there's nothing?
Yeah, I mean, is
that the idea?
If you draw the thing, you can draw a map of it, and it just literally time ends, just purely in Einstein's theory. This is 1915, his theory of general relativity. You just get a line there, a line that says there's no future beyond this. So to backtrack a bit, why does this calculation Stephen did, why has it got no information? Why does it say there's no information in this radiation? The thing is, it's coming from the horizon. So it's there's loads of ways to think about it, but one way is that this weird place, this point of no return in space, it almost disrupts the vacuum of space and sort of almost shakes particles out of the vacuum. That's one way of thinking about it. But this radiation is coming from the vacuum. It's coming from empty space. Whereas if you think about the thing that I throw in, if I throw this notepad into the thing, then that goes to the singularity. It's got nothing to do. The radiation's got nothing to do with this thing. This thing is not set on fire or something like that. It's gone to the end of time, and just whatever's happened to it has happened to it. So this radiation's got nothing to do with anything that falls in at first sight, at least. And so that was the paradox. It's called the black hole information paradox. One way to put it is the laws of nature that we use to calculate what happens tell us that information is never destroyed. And when you calculate what happens, it tells us that information is destroyed. So that's why everyone got interested in it in the 80s.
When we're looking at the structure of the universe, obviously there's so much still to learn just about what's out there. But what role do we think, is there a purpose? Is that the right term, for a black hole? Is it still do they still believe that in the center of every galaxy there's a supermassive black hole that's, 1/2 of the mass of the galaxy? Is that what it is?
Yeah, something like that. Yeah, and that's, there's occasionally a galaxy. I think one was discovered where we said maybe we can't see evidence of a black hole. But I think,
really?
So probably is what.
What do you think that thing's doing there? Like, what is that? What's the what is the structure is so insanely complex and so immense, and you see these things everywhere. And so, what purpose do you think they serve in the universe?
So, I mean,
is that a right? It might not be the right term.
Well, so I think we don't. I think I'm right in saying we don't fully understand why all galaxies, as you said, maybe there's an exception, but all galaxies have a black hole, a supermassive black hole in the centre. It's obviously got something to do with the way they form. And one of the purposes, by the way, of the James Webb Space Telescope is to try to look at the formation of the first galaxies. So that's one of the reasons that telescope is up there. So it's cutting edge research. We're trying to understand how the galaxies form. But I clearly, you're right, that it has something to do with the way the galaxies form in the early universe.
Pulling in stars.
Well, they do pull in material,
right?
But if you've got stuff orbiting around them, it stays orbiting around it.
Oh.
So the way we first detected the one in the Milky Way, before we could, because that image is very new that we have of it, is the stars orbiting it, very close to it. They're called the S stars that whiz around in these orbits very close to the black hole. So if you're just orbiting around the thing, you go.
Imagine that view.
Yeah, because
you think it's weird to look at the moon? Imagine if there was a supermassive black hole above our head.
It'd be so cool. I'd love to see one.
The moon is so cool. The eclipse was wild. We had the eclipse here in Texas.
Yeah, did you see it?
Oh, yeah. It was incredible. It's so strange. The whole day turns into night. All the birds stop chirping, and you're like staring up at this perfect eclipse. It was incredible.
Did you get this? Because I saw one in India, and I got this feeling that I was living on a ball of rock.
Right.
And it must have been just because the night just falls.
Right.
And suddenly you see the universe comes much more quickly.
I went to the Keck Observatory once in Hawaii. I've been a few times, but one time I went on the perfect night with no moon, and it was sensational.
Yeah.
It was the most. It was such a vivid image of the entire Milky Way, and every inch of the sky was covered in stars.
Yeah.
It was so phenomenal, and it made me a little upset. Because I was like, this is above our head every day, and this would radically shape the way human beings feel about our place in the universe.
Yeah.
It would greatly expand the curiosity of young people to explore space. So many more people would get involved in astrophysics. So many more people would get involved in just the exploration of the known universe because it's so majestic. And instead, we have, like, our screen is off. It's like that. It's like that screen. That's what we see because of light pollution.
Yeah.
That should be remedied.
Yeah.
Like that's not a good trade-off. Like, lights are wonderful, but it seems to me like there's got to be a way to do this where you don't ruin the view of space.
Yeah, because you know these questions we have about our place, and as you said, it can be easy to be myopic, can't it? You said if you look at our screens, it's Earth that we think about at most. And most of us don't really think about Earth. You think about your country or your city or your town.
Or your neighborhood.
Even think about the Earth. But you're right. If you know when you look at that arc of stars, and as you said, when you see it in a truly dark sky, it's powerful.
It's incredible.
400 billion suns, give or take. 400,000 million suns.
That's just words.
It's
you know what I'm saying?
To picture.
Yeah, it's insane. Your brain doesn't even process that. Like I could repeat that if someone says, "How many suns?" Oh, 400 billion. I don't know what that means. That's it's so abstract.
And most of them, I think, the best guess would be all of them have planets. So pretty much. So you're talking about trillions of planets.